designed rainwater harvesting systems and conducted water conservation audits and has received certification from USDPC and IGBC. I request Mr. Saraiya to give his talk and also request him to limit his talk to 20 minutes as we are running totally out of time today. Mr. Saraiya, please.
Yeah, good evening everybody. I will try to complete the session as soon as possible, but there are fantastic case studies that has to be shown which has been implemented across India. So rainwater harvesting in earlier speakers have shown the importance. So I will be talking how cities can benefit from rainwater harvesting, how urban areas can benefit from rainwater harvesting. India's urban areas population is expanding, and as the population expansion happens, the water requirement keeps on increasing. Rainwater harvesting is one of the factor which can reduce water dependency on the municipal corporation water supply. Now I will be sharing the urban case studies. This is one of the HPCL. Hello, please mute yourself. There is lots of background noise coming in. I request everyone to please mute yourself. This is a HPCL residential colony at Chembur in Mumbai. It is a 40-acre layout. This is a check dam what we had designed. On the backside of the colony is a 40 acres, and backside of that is a BARC hills. So inside the check dam, we have designed a recharging pit. If you can see the mouse on my screen, this is a recharging pit with a borewell. The speciality of this project that in the surrounding area and in the campus itself, the borewells used to get dried up during the summer season or before the summer season, and some borewells had gone completely dried up. So we created this check dam. We understood the geophysical and the aquifer systems. We conducted a geophysical survey, understood the hydrogeology of the locations, and accordingly drilled the borewells and created this check dam to recharge the water into the ground. After one monsoon of recharging with this check dam, the surrounding area of borewells started yielding water even in the summer season. The borewells which had gone dry started yielding water, and there was a huge greenery in this particular location. This is the layout plan. This is a natural stream that was falling, coming from backside was a BARC hill. So on this stream we created the check dam and did a recharging pit, and that helped to revive the water table in that particular area. Now after 5 years of this system implementation, all the borewells are yielding water throughout the year. Second thing, the greenery in the whole location, the rest of the area is totally green in this project. They are the greenery has improved, and they are getting continuously flushing water out of it. This location in the summer season, HPCL people allow you to go inside and have a look at the system. The importance is that gardening is now totally dependent only on borewell. Earlier they were dependent upon municipal water. They used to get water tankers in April, but now due to successful recharging, not only through check dam but through also recharging pits, the water table has increased and the water quality has improved. This is a typical drawing of a recharge pit. Water we had diverted from internal stormwater drain. It has passed through a sedimentation trap, oil trap, and then we have recharged into the ground through borewells. Through hydrogeological studies, which is the most important for designing of rainwater harvesting systems, you need to understand the confined and unconfined aquifers. And in Mumbai, being the groundwater table is up, the unconfined aquifers get saturated very fast. But you have to go into the confined aquifers and recharge multiple confined aquifers. As stated by few of the speakers in earlier lectures today, you have to be very careful that the contaminated water does not enter this recharging pits. So in residential colonies, you have to keep your surface, your stormwater drains very neat and clean. This is a section of the recharge pit. This is a storm water drain. From that water comes into this sedimentation trap come oil trap, then it comes into the recharging pit. Here, instead of having conventional sand, gravel, stones as a filter media, we have utilized a technology called V-wire filter screens. This V-wire filter screens is a technology with a BIS code, and it states that it is non-clogging, non-choking. It is a SS304 made filters, and it requires only once a year cleaning. That's all. This is the actual photograph of how the system was designed. From this nala, from this stream, we diverted the water into the sideways into the recharging pit, and we have constructed the recharging pit. This is another photograph of creating the recharging pit inside the check dam. After installation of this system, there was water availability throughout the year in the surrounding areas outside the HPCL premises. Wherever the borewells were getting dried or were dried, have started also yielding water, and this project has received a platinum certification from CII. This is another famous case study in Mumbai. It's a small project of only 700 square meters. Borewell was drilled in 2007 when the building construction started, and we got a yield of 15,000 liters per day. But unfortunately, at 50 feet, we encountered brackish water. This project is near the Khar subway. Now we did rainwater harvesting recharging of whole plot, not only the rooftop but even the surface water we recharge into the ground. For 3 years the society kept on recharging the water into the ground, and after 3 years the water quality improved, and the water availability also was non-potable quality that is now utilized for flushing and gardening purpose. Earlier they used to purchase 182 tankers annually to satisfy their flushing requirements. Every year now they are saving 91,000 rupees for water tankers. The total plot area was only 627 square meter, and it was generating around 12,000 liters of water per day. Considering that factor, we created the recharging pits. Now the recharging pit in urban areas, plots are small, lots of utilities, services are passing through. Such a recharging system has to be created that from that your utilities can pass through. From above, even your cars can pass through, or your vehicular traffic movement can happen, or even parking can happen on top of it. So this is a classic case studies. Lots of organizations from Mumbai, from other cities have visited this location as a famous case study for rainwater harvesting. This is a typical recharging pit on the borewell, and this is a V-wire filter screen kit installed on the mouth of the borewell, and to the same borewell injection is happening and extraction is happening. But this happens only in the case of where Deccan basalt or hard rock formations is there. If you go in northern India, you need to create a separate injection well and a separate extraction well. So you need to differentiate between the geological formation and accordingly they design the rainwater harvesting scheme. This is another case study of Lodha Group at Kanjurmarg. This was made in almost 2004. This is almost a 10 acre 12 acre site, and there they had a regular requirement for flushing water as well as for running their AC chillers. Any municipal corporation in India does not supply water to run water chillers, so they require makeup water. So what we did, uh, we created a rooftop rainwater harvesting collection tank and excavated 7 borewells and 7 recharging pits. The daily requirement was 1,40,000 liters for chillers. What we did is this is the IT building from where we collected the recharging, we collected the water in the monsoon season in this tank, and during the monsoon season 100% chiller water requirement was fulfilled from rainwater harvesting rooftop rainwater. The compound area water we used to recharge into the small recharging pits, and uh, during non-monsoon season we were getting water through that bore wells, and till date this system is running, and they are not dependent any from outside source of water like water tankers. Annually they are saving almost 27 lakh liters, 27 lakh rupees from water tankers purchase. This is a typical drawing. These are the two first flush chambers on two ends. Middle is a filtration chamber with a high rate of filtration. It can filter almost 2 lakh liters of water per hour. And this is a collection tank. The big square what you are seeing is a big collection tank, and there from there the water is pumped into water chillers. This is a typical section of the collection tank, how the collection system runs. So there is a saving of almost 27 lakh rupees annually, and from only 7 borewells and one rooftop water collection tank, they are getting daily 1 lakh 40,000 liters of water. This is another case study near Regal Cinema. It is called St. Anne's High School. This people is a heritage building. First of all, it's a heritage building. Second thing, they had a flooding and flushing water problem. And considering all these problems, we designed a rainwater harvesting system. We have to consider that children does not get infected due to water issues. So considering all these factors, we did recharging for one monsoon season. The flooding was eliminated, and they started getting flushing water round the year. The plot generated almost 30 cubic meter of water every day in the monsoon season, and annually almost 21 lakh liters only from rooftop. Plus the surface water was additional 20 lakh liters. All this water is harvested in each of the monsoon season. Even last year during the peak monsoon of 300 mm per day, there was no flooding in this particular plot. So you need to analyze the geological formation, understand the aquifers patterns, the movement of groundwater table, and accordingly design the rainwater harvesting recharging structures. This is another classic case studies of Prince of Wales Museum. It is again near Regal Cinema, opposite Regal Cinema. Uh, the issue was that garden used to get dried. They had a borewell of 1965. This project is hardly 300 meters away from the Navy submarine maintenance yard, and at the depth of 40 feet only. Earlier they used to get 15-20,000 liters of water, but in 2007 it had reduced to only 5,000 liters per day. We created rooftop rainwater harvesting system, and after couple of years of recharging, they are getting almost 20 to 30,000 liters of water per day. They are now not dependent upon water tankers for flushing water or for maintaining their garden water. They are self-sufficient, no flooding happening in the campus, and we have done only part rainwater harvesting. This is 4,000 square meters is the rooftop area. Out of that, only 2,000 square meter rooftop area water is diverted through underground pipeline system, and this is the recharging pit on an existing borewell. You need to have patience for doing rainwater harvesting and recharging. This is the photographs of existing borewell through which surrounding excavation done and recharging pit constructed around the borewell. This is the finishing. On the back top PCC done, and on the top again the garden was redeveloped. This is the first flush chamber, and this is a photograph of the manholes on the top. See, rainwater harvesting is a community project. You will not get the results within 1 year. You need to have patience for 2-3 years. You need to have observations, collection of data for 2-3 years. Then only you can analyze the difference and the incremental in rainwater harvesting water availability. See, by doing rainwater harvesting, there are few things that changes. Your groundwater table will come up, your water quality will improve, yield will improve, and your electricity bill may go down, as the pumping would have to be done at a shallow level. These are the few important factors which distinguishes your rainwater harvesting system and proves that your recharging system is successful. Now the recharging capacity of this only 40 deep borewell, 40 deep borewell, the recharging capacity is almost 35,000 liters per day. So the yield has increased drastically, and now they have become a self-sustainable. This is another classic case study from Vadodara. In orbit mall is developed. Earlier in that location, flooding used to happen. It is almost 8 acres of property. This is the layout plan of the property. This is the main road. The green structures what you see here are all recharging pits. They had a typical problem of water getting accumulated during the flood, and flooding used to happen. We did a rainwater harvesting recharging system. Again, for that we conducted a hydrogeological survey, understood the aquifers, designed at what level the borewells are to be drilled for injecting water into the ground, and after very first monsoon the flooding got eliminated. Today almost 8 years has passed and there is no flooding problem in that particular area. It is called alembic area of Vadodara. The importance is the groundwater table increase, the groundwater quality improved, and the quantum of water availability also increased. But at this point we need to technically understand basic, very basic thing, that by doing rainwater harvesting, it's a community project, it's not an individual project. Everybody starts doing it, the whole area will be beneficial, not an individual person. There is no specific scientific or mathematical formula okay, by injecting so much quantity of water so much improvement will happen in water quantity or in the yield or in the quality of water. It's a proven technology that changes happen, but how much nobody can predict it. So please be careful on that matter also. Coming back to this case study, we did 8 number of recharging pits and now the site is 100% flood free, plus they have started getting additional water for flushing and gardening purpose. This is another case study. This is Groundwater Board of Maharashtra. It is called Groundwater Survey Development Authority. It's a head office building in Shivaji Nagar in Pune. We have created one demo unit, demo rain artificial recharge structure at the location. Rooftop as well as surface water is recharged into the ground. You can pour water. There is a tap next to the recharging pit kept for it. Anybody can walk in. There are light manhole covers, acrylic manhole covers are given. You can open up the covers, pour water from the tap next given next to it. You can pour water, see for half an hour how efficiently and fantastically the water gets recharged into the borewell. How even the V-wire filter screens are working, how effective are there. It it is non-clogging, non-choking filters with a BIS code, and you can see the actually demonstration of that location of the recharging. I have myself conducted from last 4 years, once on every month on Saturdays. We have given uh, trainings, we have given lectures, we have given live demos to the architect association, engineering association, and various private organizations, live demo of such recharging pit. Anybody from any part of Maharashtra or India can visit inside. No special permissions are required. At the gate security you have to just inform that you have come to see the recharging pit, and they will take you to the recharging pit locations. Or if you require any support, you contact us and we will guide you further in this matter. So this is the typical ring well with a filter screen kit and the casing pipe on top of it. What everybody forgets in making recharging pit is making of ladder. The making of ladder is mandatory, otherwise the maintenance doesn't happen, and due to which the system remains defunct. So in another drawing, this is a desilting chamber, sedimentation trap. From here overflow goes into this ring well and this is whole big recharging pit filled with rubble stones, so that additional water has to be stored. Why we are creating larger recharging pits? See, as per the rate of recharge of the borewell, you need to store that much quantity of water in the surrounding area of ring well. Ring well does not have that much capacity to store the water. So you need to design the recharging pit as the capacity of rate of recharging. If a borewell is able to recharge 1000 liters per hour, so in 24 hours it can recharge 24,000 liters of water. You need to create clear water storage space of 24,000 liters. What people do, a typical, they will create a ring well of 4 feet dia, and half the ring well is filled with sand gravel stones. How much water you are going to percolate? How much water you are going to recharge? It's a namesake system. People are maximum majorly in India are following such system. Please improve your designing standards. Otherwise, we are recharge. It's a just namesake system, and hardly any quantity of water we are recharging into the ground. This is another classic case study of Mr. Mukesh Ambani's house, Reliance Industries, Antilia building. They have also done rainwater harvesting. Rooftop water is collected into an underground tank of 30,000 liters. They collect this water and they are using this water for their secondary purpose, cleaning of common lobby areas, cleaning of cars, and all other secondary purposes. This is a small case study, even a small building of 500 square meters. Now the awareness among the societies have come. This is a society case study. These people faced a shortage of water in summer season through their borewell. So they got the rainwater harvesting done. Only after one monsoon season, the shortage stopped and they started getting full water from the borewell. This is at Khar West. This is another project, Skyline Villa Powai. They used to spend earlier money for buying the tanker water. We created such a rainwater harvesting system that even in summer season they started getting the water through borewells by recharging and collection systems, and they started saving approximately 2 lakh rupees per year by not buying the tanker water. This is another case study from Goregaon, Mumbai only, and here uh, the awareness was so good in this society. They saw that in future the water problems will come, and they wanted to sustain their groundwater table and water availability from their borewells. So they came up and said, okay, no, we want to do rainwater harvesting. Right now there is no water shortage, but still they got that water recharging done, and now they are getting water constantly throughout the year. This is another society at Jogeshwari Andheri. They had a typical problem of borewell getting dried up in summer season. We did a rainwater harvesting scheme for them, and now the borewell is not getting dried. But yes, the quantum of water availability is less. Slowly, year by year, the water availability will keep on increasing. We have done rainwater harvesting in many municipal corporations across India. I am doing projects at almost 60 locations in India, and sitting in Mumbai we are able to coordinate, give the technical designs, and guide the people. This is Thana Municipal Corporation, Dadaji Kondev Stadium. For that we did rainwater harvesting almost 8 years back. Now from that rainwater harvesting recharging, we are able to get 1 lakh liters of water every day. And that water, earlier they used to maintain the greenery through municipal corporation water. Now they have reduced their intake by almost 50 to 60%, and more borewell water and recharging water is utilized to maintain their greenery. There are another buildings in the same complex like badminton hall, pavilion building. All this rooftop water, almost we are harvesting 30 to 40 lakh liters of water in one monsoon season inside the stadium. Some of the stadium rooftop water we are harvesting directly through different borewells, and different buildings are badminton hall and pavilion hall, where we are doing the direct rooftop recharging only and harvesting the water. These are the all classic case studies. uh, with the help of some municipal corporation person, you can visit the location and have a look at the systems implemented. This is a typical design of the rooftop rainwater harvesting system. First flush chamber. This is a recharging pit with a borewell and V-wire screens installed on mouth of the borewell. This is a typical cross section of the recharging pit. Total 3 number of recharging pits are implemented. Now a biggest case study is Mantralay, Mumbai. 3-4 years back Mantralay got renovated. The whatever roof water is there, that we are collecting into a collection tank. This is a collection tank. This is the building. Front building rooftop water is collected into a collection tank. Right now I am not aware for what purpose they are using. And the surface water, surrounding area of surface water, they are recharging into the ground. Near this project is near to sea. Still in the ring well, they are getting non-saline water, non-potable water. This water is used for gardening purpose, but very less quantity they are using it, as they have got a very good BMC water supply. This tank is also utilized in the monsoon season, but there is a restricted use in the Mantralay. So this is a typical design of rooftop rainwater collection tank, first flush chamber, filtration chamber with filter screens, and water collection into a tank. This whole thing has been implemented at the location, and we have handed it over to the maintenance team. They will be able to guide you further. This is a typical recharging pit. Another classic case study is NMMC headquarters, Navi Mumbai Municipal Corporation headquarters. This project is next to creek. There is a backflow of water. In low tide and high tide, the water movement is happening. Still at this location, recharging is happening. The importance is, we studied the hydrogeological studies and designed borewells accordingly. In at sea, you can see at the side there is a water creek, backwaters coming here and going as per the high tide and low tide. We designed rooftop rainwater harvesting unit of 75,000 liters. That was the only their requirement per day. So the tank of that capacity was made. Till date, this water is utilized for secondary purpose in the building. Surface water we recharge into 3 numbers of recharging pits. Total 8 number of recharging pits. Every borewell recharging is happening, and as we go 50 meters away from the creek, the borewell is giving non-potable water utilized for gardening purpose round the year. They have the STP recycling of water, but still they utilize this water for gardening purpose, and till date their garden has not got affected due to bad quality of water. That much quality of water has improved. So this is the importance of recharging and the success of recharging. So I will now go to only two more case studies, that is for industry's purpose. Few of the delegates would be interested to knowing the importance in industrial case studies. This is a pond what we had designed for Zahirabad factory of Mahindra and Mahindra. Surface water, it is almost 80 acres of land, and surface water was just flowing out of the property, and they were totally dependent upon groundwater, as they did not have any government water supply. This is a pond, and this is a filtration chamber designed before the pond. This filtration chamber can filter 6 lakh liters of water per hour. This is a layout plan of the location. It is almost 80 acres of land. The 50% of the contour is going in the backside direction, that is in north direction, and 50% of the contour is going in south direction. What we did, At this location on the backside where vacant land is written, there we created a collection pond. Every day they had a requirement of approximately 400 cubic meter of water. The borewells used to get dried up in the summer season and they were dependent upon the water tankers. No external water supply source, pipeline supply source, totally dependent upon groundwater. We did a feasibility study of entire project, created a rainwater harvesting report and master plan for the entire project. And phase wise the implementation of scheme started. In very first step we did collection pond and few number of recharging pits. The difference what it has brought is an excellent case study. During monsoon, we did not touch the borewells. Only the recharging kept on happening, and recharging happening. We collected water into the pond, and from pond, during the monsoon season, water was utilized for all purposes, including processes. Due to which the water in the aquifers remained stagnant, and that water availability happened in summer season. In first summer season the borewells were getting dried up, say in end of March. The water availability happened till end of April in first monsoon, in first summer season. As second year recharging happened, the availability of water got extended, and now right up to June they are getting the water from the borewells. They are implementing more number of recharging pits, doing more recharging. Just 3 4 days back they gave me a feedback. Now they are purchasing only 2 tankers of water per day. Earlier they were purchasing 30 tankers of water per day. See the difference. If you study the geological formation and create a report and a master plan accordingly, and create a proper recharging system, recharging units, proper filters, the project will be 100% successful. But you will require patience, some time to get some benefits out of it. This is a typical recharging pit. This is the design of the pond. From stormwater drain the water is passed through this sedimentation trap, oil trap, filtration chamber, and then the pond. This is a few photographs of the pond what we had designed and the implementation happened, and see the crystal clear water in the pond. So this is the water requirement that we fulfilled from there. This is a small case study of Godrej where daily from rooftop they are getting 150 cubic meter of water. This is in Gujarat, Bharuch. And this, due to this clean form of water, the DM chemical consumption reduced by 25-30%. Now this is a one water conservation case study of an industry. This project has received a gold certification from Greenco certification of CII. Uh, the daily water consumption we reduced drastically by 40%, and the project achieved a gold certification. This is a rooftop rainwater harvesting. Then for gardening purpose they used to buy water from the pipeline source. We created an artificial pond, natural pond, and whole year water requirement for gardening was sufficed from this. Then for water conservation program we provided a drip irrigation system, recycling of water by phytoremediation system, water efficient low flow fixtures, water monitoring, water audits. We did all these things, and their annual consumption was 22,000 meter cube annually, and now it is only 8,000 meter cube annually. We reduced water consumption of 15,000 meter cube annually. This is a classic case study of water management, water conservation, and rainwater harvesting. I think so. Now this is the last case study. This is Hindustan Petroleum case study at Andhra Pradesh. It is called Rajamundry. It is a LPG plant. We have gone up to water neutrality. Whatever water you are consuming from supply of pipeline source as well as from borewells, they were consuming almost 21,000 cubic meter of water annually. We did a rainwater harvesting scheme for that project, and we harvested almost 31,000 cubic meter of water in one monsoon season. This system is running from last 6 years, and they are saving so much of quantity of water, and now they are water neutral. They have HPCL has got third party audit done from Bureau Vistas, and they have certified that this site is water neutral. So this is a classic case study. See, if you get the systems designed properly and get it properly implemented, 100% results can be achieved. Same system, same design cannot be implemented at all locations. The basics for your studies is your geological formation, your rainfall pattern, and size of your recharging pits. These three things are the heart of your recharging or designing systems. If any one of the things are wrong or you don't get the correct data, the entire system can fail. So you need to take care of these factors. These are the classic other case studies like Tata Steel, Hindustan Platinum. Yes, this is a classic example of Jain temple where they collect 4 lakh liters of water every year. We don't allow sunlight to touch that water. The deterioration of water happens only by 5%, and they utilize this water to clean the mandir ka idol area, gold and silver utensils, and whatever prasad they are creating, they utilize only this water, and this water lasts for them 12 months in a year. In the monsoon they utilize the fresh water, and in the non monsoon season they extract water this from this 4 lakh liter tank and utilize on daily purpose. So these are the various classic case studies. As it is already 9 p.m., I would end this lecture. These are not recommended designs by us, where we have seen maximum failures throughout India by utilizing these designs. As the time has passed 9, I am not extending further, and I am bringing end to my sessions. These are the live photographs where recharging structures